Section 5.3, Day 2, Trigonometric Equations. We're still going to solve trig equations, but we're going to look at something a little different today. So if you look at kind of example 1 here, we're going to solve cosine of theta equals 1/2. Now we did this in the previous lesson, so we know that with cosine of theta equaling 1/2, we're looking at the ordered pair 1/2 comma square root of 3 over 2. So what angle is that? That would be pi over 3. So what do we know? Well, we know theta would then be equal to pi over 3, and if we're going between 0 and 2 pi, we know cosine is positive in quadrants 1 and 4, so then 5 pi over 3 would be our other angle. That would be a solution to that equation. Now that was based on day 1 that we talked about with cosine of theta equaling 1/2. Well, today what you're going to notice is now we have this angle, which is twice, or in other cases there'll be different things, but that's twice what the theta is. So how do we solve it if we say cosine of 2 theta is equal to 1/2? Well, when the argument is a multiple of theta, the general formula that gives all the solutions must be used. So going back to that day 1 when I gave you that general formula, we were only specifically looking between 0 and 2 pi, so we didn't necessarily need it. But today we're going to need it, so we're still going to set it up the same way. We're going to say, alright, well, instead of theta equaling pi over 3 and 5 pi over 3, we're going to say that 2 theta is equal to pi over 3 plus 2n pi. That's one of them, but we have a second equation for 5 pi over 3. So we also have that 2 theta is going to be equivalent to 5 pi over 3 plus 2n pi. So we can add 2 pi to that angle and still get other solutions. So we need to now solve this equation, both these equations, for theta. So we'll divide by 2 to get theta by itself. Everything gets divided by 2, and theta is equivalent to pi over 6 plus n pi. So now our solutions are pi over 6, and if you think about it, it makes sense. If you take 2 times pi over 6, what do you get? Pi over 3. And we're saying that cosine of pi over 3 is equal to 1/2. So our angle now is being multiplied by 2. So our other one, divided by 2, our other equation, will give us theta is equal to 5 pi over 6 plus n pi. And so those are our two general forms now that we will be using, but we still want all the values between 0 and 2 pi. So if n is equal to 0, then theta is equal to pi over 6 plus 0 pi, which would then just be pi over 6. That's one of our solutions. If n is equal to 1, then theta is equal to pi over 6 plus 1 times pi. And all we're doing is adding pi to pi over 6, and that would give us 7 pi over 6, still within our 0 to 2 pi. If n is 2, then theta is equal to pi over 6 plus 2 pi. Well, now that's going to put us outside that value that we need between 0 and 2 pi. Not that it's not a solution, it's just not over the interval from 0 to 2 pi. So in this case, theta would be equal to 13 pi over 6. But we don't want that one because it's not within 0 to 2 pi. And we'll do the same thing for the other side. So theta is equal to 5 pi over 6 plus 0 pi. That means theta is 5 pi over 6. That's one of our solutions. Theta is equal to 5 pi over 6 plus 1 times pi, or just pi. And then that would give us 11 pi over 6. And we're already close to 2 pi, but just to show you, 5 pi over 6 plus 2 pi would then give us 17 pi over 6. Once again, it's a solution, it's just not within our interval. So where are our answers? Pi over 6 and 7 pi over 6? And 5 pi over 6 and 11 pi over 6. So theta is equal to all 4 of these angles. And we will put these in order. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 are all the solutions to the equation cosine of 2 theta is equal to 1/2. So let's take a look at another example. So tangent of 3 theta divided by 2 is equal to 1. The argument, once again, is a multiple of theta. It doesn't have to be 2. In this case, it's 3/2. We're going to use the general form. What is the length of the period of tangent? So when we did cosine, we did the general form where it's plus 2n pi. With tangent, the period is only pi units. So when we go to create the general form, we're going to do plus n pi. So tangent of what value is equal to -1? Well, you know that is a 45. But it is -1, so we want to be over here at 3 pi over 4. So 3 theta divided by 2, we want to equal 3 pi over 4 plus n pi, because we know we can add pi to get any more values. But we do need to isolate the theta, so how are we going to do that? Well, we can multiply everything by 2. That will give us 3 theta equals 3 pi over 2 plus 2n pi. And then we can divide everything by 3. So theta is equal to pi over 2 plus 2/3 n pi. So there's the formula that we're going to use, and once again we'll do the same thing we did last time, is that we will start with n equals 0, so that'll just be theta equals pi over 2, because everything will cancel out. Then we'll do n equals 1, and that's pi over 2 plus 2/3 times 1, which is just 2/3, so 2/3 pi. So what is that going to equal? That will be equal to, theta is equal to, find a common denominator, which would be 6. And so we would get 3 pi over 6 plus 4 pi over 6, which would be 7 pi over 6. That's still within 0 to 2 pi, so we'll do the next one. Pi over 2 plus, and then now this will be 2/3 times 2, so that'd be 4/3 pi. And then theta would be equal to, on this one, once again, finding the common denominator. So theta would be equal to 11 pi over 6. And right there, 11 pi over 6 is 1 5/6, so it's really close to the 2 pi. If I add another 2/3 to that, it's going to go over. So our answers would be theta is equal to 7 pi over 6, but before that one we got pi over 2, 7 pi over 6, and 11 pi over 6. So just remember, if you're doing sine and cosine, it has a period of 2 pi, but tangent has a period of pi. So when you go to use your general form, if you're dealing with tangent, it's plus n pi. If you're dealing with cosine or sine, it would be plus 2n pi. Alright, on example 3, we have tangent of the quantity theta minus pi over 2 is equal to 1. Once again, same idea as we want to think to ourselves, tangent of what is equal to 1. So we know that this is going to be tangent of pi over 4. That's what gives us 1. So we will set that up. Theta minus pi over 2 is equivalent to pi over 4, that's what we want it to equal, plus n pi. So we'll do the same thing we did on the other one. Now this one is addition and subtraction, so we're going to add pi over 2 to both sides. Find that common denominator, which in this case would be 4. So that would be 3 pi over 4 plus n pi. And so once again, when n is equal to 0, that would just give us 3 pi over 4. When n is equal to 1, and all you're doing is adding pi over and over again. So if you don't want to plug in n equals 1, all you have to do is take your previous and add pi to get to the next one, because that's that multiplier in terms of that that you can add to get to the next angle. So if we add pi to 3 pi over 4, that would be 7 pi over 4, which is still good. And then if we add pi to that, then we would get 11 pi over 4, which is bigger than 2 pi. So our only answers for this equation are theta equals 3 pi over 4, and 7 pi over 4. All right, let's take a look at the last example here. Why don't you try this one on your own? It's the same idea as the last one. You just have to ask yourself the question, what value of cosine is going to give you -1? So why don't you go ahead and pause the video and see if you can work through this one yourself. All right, cosine is -1 at pi. So we're going to set this whole thing up. Theta divided by 2 plus pi over 3 is equal to pi plus, and cosine has a period of 2 pi, so plus 2n pi. Now we have to solve this whole thing for theta, so we could do a couple different things. Let's go ahead and subtract pi over 3. Then all we'll have left is theta divided by 2. And so 3 pi over 3 minus pi over 3 would be 2 pi over 3. Still plus your 2n pi, that didn't change. Now everything gets multiplied by 2. So theta is equal to 4 pi over 3 plus 4n pi. So that's changed a lot at the end. If you add 4n pi, you're going to be over or outside that 2 pi that we have to be within. So this one we're not going to have a lot of solutions for. So if we have n equals 0, theta is equal to 4 pi over 3. And I'll just show you if n is equal to 1, well, since my multiplier is 4 pi, if I add 4 pi to 4 pi over 3, that's definitely going to put me outside that range of 2 pi. And so this one, whatever it is, isn't even going to matter. So it looks like we only have one solution, and that is 4 pi over 3. So that is it for the day 2 of trig equations. In terms of your summary, once again, what is those important pieces? What are those important pieces that you need to write down for this section? Especially with this being, the multiplier. If we have theta times some value, we're going to have to use that general form.